Hello and good evening to all of you. I hope all of you are doing well and all of you are in good health. Moving ahead, in today's class, we will discuss variance, covariance, and correlation. We'll try to understand each of these concepts with the help of suitable examples. Let us start with variance. Variance is a measure of how far each value or data point in the dataset is from the mean. Let us try to understand the steps that are involved in calculation of variance. Step number 1. Subtract the mean from each data point. The result of the subtraction gives the distance of the data point from the mean. Step number 2. Find the square of each of these distances and add them all. Step number 3. Divide the sum by the number of instances. So variance takes the following form. Variance is equals to sum of squares of the differences of the data point from the mean divided by the total number of instances. In other words, variance is square of the deviation. Now let us try to understand variance with the help of an example. So here we have 10 data points in the data set, which are 9, 2, 5, 4, 12, 7, 8, 11, 9 and 3. So first we have determined the difference of the data point from the mean. Then we have found out the square of the differences. Eventually we have added all the squares of the differences and divided it by the total number of instances. So here variance is equals to 10.394 with mean as 7. Now let us move on to covariance. Covariance is a measure of the relationship between two random variables. It determines to what extent the variables can change together. In other words, it is essentially a measure of the variance between two variables. There can be two types of covariance: positive covariance and negative covariance. Positive covariance indicates that two variables tend to move in the same direction, whereas negative covariance reveals that two variables tends to move in the inverse direction. The representation for covariance is as follows. Covariance of x and y is equals to sum of product of differences of the values in the data point from the respective mean divided by the total number of instances. So depending on whether we are finding population covariance or sample covariance, we may divide the sum by n or n minus 1 respectively. So let us try to understand covariance with the help of an example. So here I have taken 10 instances of x and 10 instances of y. So first we have determined the difference of the data points from mean of x. Then we have found out the differences of the data point in y from mean of y. Then we have found out the product of the differences. Eventually we have found out the sum of the differences, which is equals to minus 82.5 divided by the total number of instances, that is 10. So in this case covariance is equals to minus 8.25. So here sign of covariance represents whether we have positive covariance or negative covariance. So positive covariance has positive sign for the value of covariance, whereas negative covariance has negative sign for the value of covariance. Now, let us move on to correlation. Correlation is used to test the relationship between variables. It shows how things are related. The study is called as correlation analysis. Now, some of the examples of high correlation are your caloric intake and your weight, the amount of time you study, and your GPA. Correlation are useful because if we can find out what relationship variables have, we can make prediction about future variables or future behaviors. So correlation is represented with the help of an important coefficient. This is called as correlation coefficient. So correlation coefficient is represented by R, which takes the following form. Correlation coefficient is equals to covariance of x and y divided by the product of deviation in x and deviation in y. So this is the representation for correlation coefficient. A correlation coefficient determines the degree to which changes to the value of one variable predicts changes to the value of another. Correlation coefficients are expressed between positive 1 and negative 1. Positive 1 refers to perfect positive correlation, which implies variables are moving in the same direction. Minus 1 represents perfect negative correlation, which implies variables are moving in opposite direction. And 0 indicates there is no apparent correlation between variables. Towards plus 1, it represents positive correlation. Towards negative 1, it represents negative correlation. Towards 0, it represents weak correlation. A value of correlation coefficient greater than 0.8 is considered to be strong, and value of correlation coefficient less than 0.5 is considered to be weak. So this is the way how the value of correlation coefficient is interpreted. So here I have taken up an example for explaining correlation coefficient. So first we have taken 10 instances of x and 10 instances of y. Then we have found out the differences of data points from mean of x, and then we have found out the square of differences. Likewise, we have found out differences of data points in y from mean of y, and we found out the square of differences, and then we have found out the product of differences in x and differences in y. Eventually, we have estimated correlation coefficient as covariance of x and y divided by deviation in x into deviation in y, which equals to minus 8.25 divided by root of 8.25 into root of 8.25, which will give you minus 1. This implies that there is perfect negative correlation between the two variables x and y. So this is the way how correlation is determined. Now we have an alternative mechanism for determining correlation coefficient. This is called as Pearson's correlation coefficient. Pearson's correlation coefficient is a very helpful statistical formula that measures the strength of correlation between variables and relationships. So here the equation takes the following form. R equals to n into summation of product of x and y minus summation of x into summation of y divided by root of product of n into summation of squares of x minus square of summation of x into n into summation of y squares minus summation of y whole square. So this is the equation for Pearson's correlation coefficient. So here n is the number of pairs of scores. Summation of x, y is the sum of products of paired scores. Summation of x, the sum of x scores. Summation of y, the sum of y scores. Summation of x square, the sum of squared x scores. Summation of y square, sum of squared y scores. So these are the elements of Pearson's correlation coefficient. So you can apply Pearson's correlation coefficient to the values of x and y represented in the previous example. So in this class, we have learned about what is variance. We have learned about variance with the help of an example. Then we moved on to covariance, wherein we have discussed what is positive covariance and negative covariance. Then we have discussed the formulae for covariance for population and sample. Subsequently, we have tried to understand covariance with the help of an example. Then we moved on to correlation, where we learned about correlation analysis and we learned about correlation coefficient. We also learned about how to interpret the values of correlation coefficient, and we try to understand it with the help of an example. Eventually, we discussed Pearson's correlation coefficient, where we have discussed the various elements and the importance of the elements. So, this is the end of the second unit. Thank you very much and have a good day.